Bucci from Temple University in the United States, and the title of his presentation is The Spreading of Xylella fastidiosa subspecies pauca among the olive orchards of southern Italy, Apulia.
So where's my point? Okay. This one is forward. Backwards. Yep, I'm pointed. Okay, so thank you very much. We heard a lot about models. Now I will present something about the data. And basically, I will rely on the bunch of information which was obtained through two kind of sampling that were occurring in southern Italy in Apulia. One is the well-known monitoring program from the local government, which sampled hundreds of thousands of plants over years. And the other is a small, less-known data set, which is instead the data set of the data accumulated by the workers of the so-called TAP Trans-Adriatic pipeline. So you may know that there is a gas pipeline which is currently being built connecting Albania and Apulia, and the company which is building up it started very early sampling olives along the working plots. So in that case, we have data on olives that were completely sampled, so all olives in different plots were completely sampled well before Xylella was detected there. So we are from time zero onward. We won't go to point A, because this was the subject of another older presentation and publication. We will try to get some hints to assess the epidemic spread in Apulia, how this spread, and then we will try to put the uprooting policy on test with regards to radius of uprooting and eradication around infected plant. And then we will also spend few words about the monitoring efficacy, so the efficacy of the monitoring strategy which is currently undergoing in Apulia. So first of all, if you have data on several thousands of infected olives, you can try year by year to calculate for each olives the geodesic distance of the nearest infected olives. So you have one infected plant, and you want to know how far is the nearest infected plant from this one. So if you look, for example, to the several thousands of infected olives which were detected in these data sets, so between 2017 and 2018, this is the results. So you have that nearly 2,000 olives are at a maximal distance of 10 meters from another infected plant, and so on. And you can start considering you can start really answering some question about the radius of eradication, because you see, for example, that 98% of plants that were detected as infected in this monitoring campaign are at a distance which is a maximum of 100 meters from another infected olives. So they are all in a radius of 100 meters from some other infected olive, okay, which was detected the same year. If you look, for example, for 50 meters distance, you see that still 95% of infected olives are at such a distance, at least in this particular data set. But if you look to 10 meters radius, you see that only 48% of the olive trees are included in a 10 meters distance from the nearest infected plant. And you can visualize this information thanks to the geolocalization of the data. This is one of the several orchards which were sampled. You see here olives in red that were sampled in 2017 and found infected. Olives in violet that were found infected in 2018. Here there was eradication in 2018. You see that this is not according to the mandatory measurement, because it followed the property instead of being in a radius of 100 meters. And if you draw a radius of 100 meters around each infected tree which was detected in 2017, you see that you will cover all plants detected in 2018. Instead, if you do the same with a 10 meters radius around infected plants, you see that several infected olives escape uprooting eradication. This is irrespectively of the fact that eradication was really applied or not. But you can also have some more consideration, and you can draw some more conclusion from the data. Here you see in red the olive trees that were found infected in 2016, in here full red, and then you have in dark red and in violet olive trees that were found infected in 2018. You see that there are in violet plants that are in the radius of 100 meters from a previously detected infected plant. In dark red, you have plants that are far, so they are outside 100 meters radius from a previously detected infected plant. Nevertheless, all those plants are grouped, are tightly clustered, in clusters that are, again, all included more that we will see in 100 meters radius. So this is the distribution of distances from previously detected infected trees of new detected infected trees. Differently from what you see by considering all data in a single campaign, if you compare the data from a new campaign to an older one, you see that there are hotspots that are, you see, 600 meters away, 800 meters away, up to more than 1 kilometer away. And if you clusters all plants according to their distance from other plants, so you decide, okay, let's consider all clusters of infected olives in a 100-meter radius from another infected plants. So instead of reasoning on single plants, you start considering clusters of plants. You see that most of the newly detected clusters in 2018 are at large distances. 77% of them are at large distances from previously detected cluster in 2016. That means, since they all are grouped in clusters, so still the local dynamics is in 100 meters radius, that means that your monitoring strategy is somehow failing and letting those new clusters escape 1 year after the other. So we have a big detection problem here. Going to the other data set, so starting the top plots, in this case, we have several different plots that are scattered along the direction of the gas pipelines to be built in Apulia. And they started, you can see here the example for two plots. One is this one, and the other is this one. They started sampling around 2016. Both of them were completely free. Those two plots were completely free when they started sampling trees, were free of Xylella. Once Xylella is established, more or less between the end of 2016 and starting of 2017 in both plots, you see that for some times, as you could already assess by the several models we had the opportunity to look at, this is maintained at low detection rates, you see. Only, for example, in 2017, in this plot, there is only roughly 4% of olives that were found infected, to explode after 2 years from the first detection in a plot. And if you take all those plots, you can start simply interpolating this data if the spread for plots is not too much, so if there is not a huge variance among plots, and this is indeed the case, and you get the first ramping up, of course, of the kinetic of the epidemic, which is pretty much exponential. And you can see that you can infer that the true spread of infection, so the sensible expansion of an infection over 50% of the trees infected, is only achieved after 3 years, which is fully consistent with what people saw on the ground, and which also are consistent with the fact that there is so much social opposition to the eradication measure, because for the first years, people only see few trees, if any, showing symptoms, and only after 3 years, they start to notice that most of the trees show are infected or show some sign of infection. So this is obviously in agreement. I mean, the exponential interpolation is for the first phase of the local spreading is in agreement with several models. Here I just put one to justify why I use this exponential interpolation here. And you can conclude that first, at the forefront of the infection, where the monitoring occurs, so in the part of Apulia of new infection, the epidemic proceeds by establishing tight groups of infected specie, as we heard, also by the modeling efforts. But the important thing is that most of those groups are including all trees which are not separated by a distance superior to 100 meters from another infected plants, which has obvious consequences for the eradication efforts, or for the containment efforts in this case. Then you can see that under the current monitoring strategy, these imply that, I mean, there is pretty good ground to eradicate in 100 meters radius if you are able to detect infected plants, because the problem is that most newly infected plants are far from previously detected plots. If you go from 1 year to maybe 2 years after. And this point either to long-range spreads, this is one component, but the other component for Apulia is failure in monitoring, and we know of this. So 77% of new infection hotspots are found at more than 1 kilometer from old infection hotspots. At local level, the initial, of course, dynamics is exponential, and we have enough data to confidently predict how long time will pass on average before some orchards is completely destroyed. And this fits with all the field observations which are reported by the growers, but also fits with the social process dynamics, I would say. So I thank you for your attention, and I'm ready for questions.